Hi everyone, my name is Irene. Today's video will be on lines, transversals, and the angles created by them. We'll be discussing the different types of lines and different types of angles, then doing some practice examples with them. Let's go over the definitions of some terms first. A line is a collection of points that extend infinitely in both directions. A ray is like a line, except it starts from an endpoint and extends infinitely in only one direction. A line segment, on the other hand, has two endpoints, like line segment AB here. Lines can have relationships with one another. For example, parallel lines are lines that never intersect. They extend infinitely in the same directions. Since these two lines change at the same rate, we can also say that they have the same slope. We can tell if lines are parallel if they're the same number of slash marks through them, like so. We can also tell if they're parallel if it's given in the problem. The notation for parallel lines is two straight lines between the names of the lines. Unlike parallel lines, intersecting lines pass through the same point. Here we can see that line P and line Q intersect at this point right here. If lines intersect at a right angle, they are called perpendicular lines. We can tell if two lines are perpendicular to each other if there is a right angle created at the intersection, denoted by a square. It might also be given in the problem. The notation for perpendicular lines is this symbol between the names of the lines. If two or more lines are intersected by another line, this line is called a transversal. Here we can see that transversal T cuts through lines M and N. When a transversal cuts through parallel lines, angles with certain properties are created. As we can see by the notation here, lines M and N are parallel to each other, and transversal T cuts through these lines. As you can see, there are 8 different angles created by this transversal. There exist many relationships between these angles, including corresponding angles, vertical angles, consecutive exterior angles, consecutive interior angles, alternate exterior angles, and alternate interior angles. That was a lot of vocabulary that I just threw at you, so let's go over what each of those terms means. Corresponding angles are angles that are in the same position along a transversal. For example, angle 1 is on the left side of the transversal and above line M. The corresponding angle to angle 1 would be angle 5, which is on the left side of the transversal and above line N. Corresponding angles are congruent. In other words, they have the same angle measure. Conceptually, this makes sense. Line M and N have the same slope, so a line that goes through both of them would cut them at the same angle. In other words, we could move line N so that it completely covers line M at every point, so the angle measure between the transversal and these two lines would be the same. When two lines intersect one another, such as line M and transversal T, there are opposite sets of angles that are created. For example, angles 1 and 4 are opposite one another, and angles 2 and 3 are also opposite one another. These angles are known as vertical angles, and they are congruent. So, if angle 2 was 80 degrees, angle 3 would also have a measure of 80 degrees because the two are vertical angles. The interior involves the angles that are between the two parallel lines, such as angles 3, 4, 5, and 6. The exterior involves the other angles that are on the, quote, outside, such as angles 1, 2, 7, and 8. Consecutive exterior angles are angles that are on the same side of the transversal and on the exterior side of the parallel lines. For example, angles 1 and 7 are both on the left side of the transversal, and they are both on the outside, so there are consecutive exterior angles. Consecutive exterior angles are supplementary. Here we can see that angles 1 and 3 are on one side of a line, meaning that they add up to 180 degrees. Thus, angles 1 and 3 are supplementary. Angles 3 and 7 are corresponding angles, so they are congruent. Since angles 1 and 3 add up to 180 degrees, and the measure of angle 3 is equal to that of angle 7, we can say that angles 1 and 7 are supplementary as well. This is known as the substitution property, and it will be gone over in more detail in another video on proofs. Consecutive interior angles are the same, except that the angles are between the two parallel lines. For example, angles 3 and 5, which are both on the left side of the transversal and between the two parallel lines, are consecutive interior angles. Consecutive interior angles are also supplementary. Angles 5 and 7 are supplementary because added together they create a straight line. Like we said before, angles 3 and 7 are corresponding angles, so they are congruent. Since angles 5 and 7 add up to 180 degrees, and angles 3 and 7 are equal, we can say that angles 3 and 5 also add up to 180 degrees. Alternate exterior angles are angles that are on the outside of the parallel lines, but on different sides of the transversal. For example, angles 1 and 8 are on opposite sides of the transversal, and they are both exterior angles, so there are alternate exterior angles. Alternate exterior angles are congruent. To prove this, we must first know the transitive property of equality. The transitive property of equality says that if A equals B and B equals C, then A also equals C. Now let's use this to prove that angles 1 and 8 are congruent. Angles 1 and 5 are equal because they are corresponding angles. Angles 5 and 8 are equal because they are vertical angles. By this property then, angles 1 and 8 also must be equal. Alternate interior angles are similar, except that they are between the parallel lines. For example, angles 3 and 6 are on opposite sides of the transversal, and they are both interior angles, so there are alternate interior angles. Alternate interior angles are also congruent to one another. We can also use the transitive property of equality to prove that this is true. Angle 3 is congruent to angle 7 because they are corresponding angles. Angle 7 and angle 6 are congruent because they are vertical angles. Thus, angles 3 and 6 must also be congruent. Now let's practice using these properties to find out the measures of all 8 angles when one is given. Let's assume that lines P and Q are parallel for the first problem. Here it is given that the measure of the exterior angle is 137 degrees. Angle 4 and angle 1 are vertical angles, so they are congruent. Thus, angle 4 is also 137 degrees. Angle 5 and angle 1 are corresponding angles, so they are congruent. Angle 5 and angle 4 are also alternate interior angles, so they are congruent. By using the properties of either of these angles, we can say that angle 5 also has a measure of 137 degrees. Angle 8 and angle 1 are alternate exterior angles, so they are congruent. Angles 4 and 8 are corresponding angles, so they are congruent. Angles 5 and 8 are vertical angles, so they are congruent. I think we can confidently say that angle 8 also has a measure of 137 degrees. Now to find the rest of the angles. Angles 1 and 2 are supplementary because together they create a straight line. Supplementary angles add up to 180. If we subtract 137 from 180, we get 43 degrees as a measure of angle 2. Since angles 2 and 3 are vertical angles, they are congruent. You could also calculate angle 3 based on the fact that angles 1 and 3 are also supplementary, but this method would take more time. Angles 2 and 6 are congruent because they are corresponding angles. Angles 3 and 6 are alternate interior angles, so they are also equal. Thus, angle 6 is also 43 degrees. Angles 6 and 7 are vertical angles, so they are equal. Angles 3 and 7 are also corresponding angles, and angles 2 and 7 are alternate exterior angles. Thus, angle 7 is also 43 degrees. Now try the next problem on your own. Let's assume that lines A and B are parallel to one another. You can pause the video for however long you need to solve the problem. The answer will be revealed in 3, 2, 1. Did you get all the angle measures correct? That's it for today's lesson. Thank you so much for watching. If you want more practice, there's an additional worksheet and its answer key attached in the description box below. If you have any questions, concerns, or comments, don't hesitate to contact me at the email address below. It's also linked in the description for your convenience. If you have any requests for future videos, please submit one on our website, taskteam.org, which is also linked in the description. Until next time!